In this video, I'm going to cover questions 21 through 25 of the 1997 Grade 9 Pascal Math Contest. In the diagram, the adjacent edges are at right angles, the four longer edges are equal in length, and all of the shorter edges are also equal in length. The area of the shape is 528. What is the perimeter? The four longer edges, so I'm assuming they're talking about these right here, are all equal, so I'll just call those X. The and all the shorter edges are also equal in length, so I'm assuming these smaller ones. They're all equal, so I'll call those Y. And they're saying that the area of the shape is 528. So area is 528. Now what I'm going to do is I'm going to divide this shape into smaller squares. Like that. And the hope is that when I drew all those lines in, it made you realize that this shape can be broken up into identical squares. And there are 33 of these identical squares. And if you have a square, and we've denoted that the length is y, then all the sides are y, and therefore the area of the square is y squared. So we can combine all of this information. We have 33 squares, total area is 528, and the area of one square is y squared, so therefore 33 times y squared is equal to 528. So solving for this, we get 528 over 33, and y squared therefore is 16, and y is 4. Now looking back at the diagram, what is x equal to? Well, x looks like it's really just 3y. So if y is 4, that means x is equal to 3 times 4, which is 12. Now, the question is asking about the perimeter, P. So what is the perimeter? Well, the perimeter is 4 of these x's, so 4x, plus a whole bunch of y's. And how many y's are there? Well, if you count, you will see that there's 24 of these y's all over the diagram. If you count all of them, you'll see that it totals 24, like that. So you just plug in your numbers, 4 times x, which is 12, 24 times y, which is 4, and you would get 48 plus 96, and this is equal to 144. So the perimeter is 144, so the answer is C. If 97 over 19 equals this big equation, w, x, y are positive integers, then what is w plus x plus y? Okay, so we're going to have to do a lot of algebra here, but instead of numbers, we've got letters. So just carefully do this. On this side, we'll have to multiply top and bottom by y to get a common denominator, and then invert and multiply this one, so it'll be like that. And then this, we're going to have a common denominator, xy plus 1, xy plus 1 times w plus y over xy plus 1. And this is going to give us w xy plus w plus y all over xy plus 1, and this is 97 over 19. So this is what we simplified to. Now, does this help us in any way? Well, 19, if you look at the bottom part, the denominator, is xy plus 1. So therefore, xy is equal to 18. And if you look at the numerator, 97 is equal to wxy plus w plus y. Well, xy is equal to 18, so we can substitute that in there. W times 18 plus w plus y. And this becomes 19w plus y. So we are going to have to deal with these two equations. And we want integer solutions. So we'll make a little table, x, y, and w, and see what we get. So if x times y is 18, the only possible integer solutions are 1 and 18, 2 and 9, 3 and 6, 6 and 3, 9 and 2, and finally, of course, 18 and 1. So for each of these, we're going to just substitute back into this equation. And let's see what we get. So if y is 18, and you substitute y equals 18 here, and solve for w, you will get w equal to about 4.5. And this is no good because we want integer solutions. All three, x, y, and w have to be integers. If we substitute y equals 9, we will get 4.63 for w. Y equals 6 will give us 4.78. No good. Y equals 3 gives us 4.94. Y equals 2 will give us 5. So that's good. And finally, y equals 1 would give us 5.05. So the only integer solution to this is right here. When x is 9, y is 2, and w is 5. Now what is the question asking us? What is w plus x plus y? Well, w plus x plus y is 5 plus 9 plus 2, which is 16. And therefore, the answer to this question is A. Determine all ordered pairs that satisfy x minus y squared plus x squared is 25, where x and y are integers and x is greater than or equal to 0. The number of different values of y that occur is. So you have x minus y squared plus x squared is 25. And notice these are perfect squares. And two perfect squares have to add up to 25. So the only way this can work is if you have the possible combinations of 0, 25, 25, 0, 9, 16, and 16, 9. These are the only perfect squares that would add up to 25. So for example, if you put 1 and 24, that would work in the sense that it would add up to 25, but 24 is not a perfect square. So you can't have that. So we can only work with these four scenarios, and let's see what we get. So the first one is when x squared is equal to 25, this one right here. So x is equal to plus or minus 5, but remember, in this question they're saying x is greater than or equal to 0, so it cannot be a negative number, so x is 5. If you plug that back into this part of the equation, you get x minus y squared is equal to 0. 5 minus y squared is equal to 0. 5 minus y is 0, therefore y is equal to 5. So we'll make a little table here, x and y. So this first one gives us x is 5 and y is 5. So we're done with this one. Let's keep going here. Let's go to the next one, which is 25 and 0. So remember, x squared is represented by the 0. So that means x is 0. And then x minus y squared is going to be equal to 25. So that means 0 minus y squared is 25. Minus y is equal to plus or minus 5. Y is equal to plus or minus 5. So now, with this one, we get solutions of 0, 5, and 0, negative 5. Okay? Now let's move forward to the next one. The next one gives us x squared is equal to 16. X is equal to plus or minus 4, but x cannot be negative, so x is 4. And then therefore x minus y squared is equal to 9. 4 minus y squared is equal to 9. 4 minus y is equal to plus or minus 3. And solving for this, you'll get y is equal to 1 or 7. So now we've got 4, 1, and 4, 7 as our additional pairs. And finally, we have this scenario here, 16 and 9. So x squared is equal to 9. X is equal to plus or minus 3. X is equal to 3 because x cannot be negative. And therefore x minus y squared is equal to 16. 3 minus y squared is 16. 3 minus y is equal to plus or minus 4. And solving for y, we get negative 1 and 7. So finally, we have 3, negative 1, and 3, 7. So what was the question asking us, if you remember all the way back in the beginning? The number of different values of y that occur is. Well, how many different values of y did we figure out? We got 5, negative 5, 1, 7, and negative 1. So we have 5 different values of y. So the answer is choice C, sorry. Two ships, one 200 meters in length and the other 100 meters in length, travel at constant but different speeds. When traveling in opposite directions, it takes 10 seconds for them to completely pass each other. When traveling in the same direction, it takes 25 seconds for them to completely pass each other. The speed of the faster ship is in meters per second. So we have two ships. We'll call them ship A and ship B. And then the faster ship, we'll call its speed x meters per second. And the slower ship, we'll call it y meters per second with regard to its speed. So the first scenario is when these ships are going in opposite directions. So basically, if you have one ship like that, this is the one that's 200 meters in length and it's going this way. The other ship, which is 100 meters in length, is going that way. So if you put this in a mathematical equation, you're basically going to get x plus y the two speeds, are equal to the two lengths, which is 200 meters plus 100 meters, divided by the time it takes for them to completely pass each other, which they tell you is 10 seconds. So this is 300 meters over 10 seconds, which is 30 meters per second. Now, if they're going in the same direction, you would do pretty much the same type of mathematics, and the scenario, of course, would be where one ship is going that way and another ship, which is 100 meters, is going in the same direction. So in this case, because they're in the same direction, you'd have to subtract their speeds, and that would equal the length of the first ship plus the length of the second ship over the time it takes for them to completely pass each other, which is 25 seconds. So this becomes 300 meters over 25 seconds, which is 12 meters per second. So we've essentially gotten two formulas. We've gotten x plus y is equal to 30, and we've got x minus y is equal to 12. If we were to work with these two, we could probably solve for x and y. The first thing I notice is that if you add these two, you get 2x equals 42. The y's cancel. X is equal to 21. And if you substitute 21 back into any of these, like for example, x plus y is 30, 21 plus y is equal to 30, y is equal to 9. So the faster of these two ships is 21, this one right here. So that would give you answer D. In the diagram, the right prism has quadrilateral base EFGH with right angles at E and G. The height of AE is 32. The distance from A to G is... Well, what is A to G? We'll have to draw that in here. It's that right there. So I drew a line from A to G to represent what the question is asking. Now the key to this question is to draw another line from E to G, like that. And therefore, this triangle, that is AEG, will help us figure out this question. So I'm going to draw that triangle over here without messing up the diagram. Now, notice that when you do that, you will create a triangle with a right angle. And where is that right angle? It's right here. Because EG lies on the base, which is flat, and AE is essentially perpendicular. Now, AG is what they're asking for, so we'll label that X. AE they've given us is 32. And EG we don't know yet, so we'll call that Y. So from Pythagoras, we can immediately see that 32 squared plus Y squared is equal to X squared. So that's the first part of the question. Now what I'm going to do is I'm going to draw the base of this diagram separately and work with that. So the base of this diagram is right here. So I'm going to draw that out. So I'll label it E, F, G, and H. So essentially exactly like the base in the diagram, I just drew it out separately. And then I'm going to draw two diagonals like that. And just for the sake of completion, we'll call the center K, this point right there. Now we have to fill in some numbers. They've given us a lot of information. They've told us that This is 15, so therefore this is 15. This is also 15. From the diagram, you just copy the numbers they've given you. This is 20, and this is 20. Now, this diagram, if you notice, has an isosceles triangle here and an isosceles triangle there. So if you're going to draw a perpendicular from H to K, like that, and that makes it a 90 degree, then you've cut EG in half. So EK will be the same as KG, like that. That's just a fundamental property of isosceles triangles. So let's label EK A, and therefore KG is A. And that's going to help us. So this is the figure that we're going to work with. So now notice that if you look back at the diagram, they've told us that E right here has a right angle. So that means this is a right angle. So from Pythagoras, you know that 20 squared plus 15 squared is equal to HF squared. So that means 400 plus 225 is equal to HF squared. HF squared is 625. So HF is the square root of 625, which is 25. Now I'm going to call this B from H to K, and therefore K to F is 25 minus B. Okay? Now you'll notice in this triangle right here, it's a right triangle. So we can again use Pythagoras. We have B squared plus A squared is 20 squared. And then in this triangle here, very similar, we also have a right angle, so we can use Pythagoras there as well. And that would be A squared plus 25 minus B squared is equal to 15 squared. And these are the two equations that are going to help us solve this problem. So let's expand this one here. We got A squared plus 625 minus 50B plus B squared is equal to 225. And therefore, if we take this equation and substitute it into this one, you'll notice that we can solve for this. So this equation basically gave us A squared plus 625 minus 50B plus B squared is equal to 225. But A squared and B squared we have here is equal to 20 squared. So we put that in there. 20 squared is 400. And then we just keep going here. 225. Put the 50B on the other side. And you got 400 plus 625 minus 225. And this becomes 800 is 50B. And therefore, finally, B is equal to 16. Okay? Now, what is B? Well, B is right here. That distance from H to K. So we can use this formula to solve for A. So B squared plus A squared is equal to 20 squared. So we have 16 squared plus A squared is 400. A squared is equal to 400 minus 256. a squared is equal to 144. A is equal to 12. So therefore, we are almost done here. This is 12. Now, what do we need to find out in this question? Well, we first need to find out the length from E to G. And if we have that, we can solve for x. Well, E to G is essentially 2a. So EG is 2a, and if a is 12, like we figured out down here, a is 12, that means EG, which is 2a, is 24. And then finally, we can therefore just solve for x, which is AG, which is what the question asks us. So we have 32 squared plus 24 squared is equal to x squared. And this is going to be 1024 plus 576 is equal to x squared. And if you solve for this, you will get x is equal to 1600, x squared that is, and finally x is equal to 40. And that x represents the length from A to G, which is what the question is asking. So the answer to this is B.